What is
voltage transfer function?
This call is now being recorded.
okay? So G12 is voltage transfer function. This circuit is given. The resistance is 1 ohms. Capacitor. Then inductor 2 Henry. Again a capacitor. Okay, just a second. Here there is a inductor. Here there is inductor. Then capacitor. Okay, and then rest of the circuit. Value of inductor is 1/3 Henry. Value of capacitor is 1/4 Farad. Okay. Then here on input side V1 with current I1, output port V2 and current I2 is equal to 0. Okay, so yes, this is what the numerical which is given, and you have to find out the value of G12. So based on the equation of G12, you can decide whether to apply all the steps here or not. That completely depends on you. Okay, so can you just start solving this numerical? Yes, who attempts first? Let us check.
Ohm's law in the circuit. Lap.
Yes, or if you start applying the rules, steps, and get it fast. Let us convert this particular circuit into Laplace transform first. So I start from this end. Here there is a resistance, then a node, then inductor. Let me check that inductor is 2 Henry. Yes, it is 2 Henry. Then node and 2 port network. Sorry, second port. Okay, then in between you have again inductor. Okay, resistance Laplace transform is same, 1 ohm. Inductor Laplace transform is 2 into S, Ls. Here it is also Ls. But the value of inductor is 1/3. So therefore you get S/3. Then 1 upon Cs. The value of capacitor is 1/4. Please remember this, 1/Cs. So 1/Cs means 1/4 into S. So you get 4 in numerator. So it is 4S. This is V2. Value of I2 is equal to 0. This is node A, whose value is VA. This is node B, whose value is VB. Then this current is I1. This current is IB. This current is IA. This is V1. Okay, then loop 1, loop 2, loop 1, loop 2. Okay, orientation for both the loops is clockwise. Without mentioning that current, you have to consider. And here you can write, fine, we have IB. Now I2 is equal to 0, therefore the current through this particular 4 by S branch is same. It is IB. Okay, without wasting time, here you can write VB is equal to V2. Okay, then apply Ohm's law. Ohm's law says IA, right? IA is equal to VA, barabar, upon this inductor is S by 3. So right there, it is S by 3. So therefore you get 3 VA upon S. 3 VA upon S. Okay, so this is 3 VA upon S. Second Ohm's law equation. I just write it here. Okay, now here you get another Ohm's law equation that is written for IB. So IB is equal to, I think all of you can see this top of the slide, IB. If you don't see, let me know so that I can accordingly do the arrangement. IB is equal to VB upon 4 by S, and therefore it is equal to, now VB is equal to V2 and S goes in numerator, so therefore it is S V2. VB is equal to V2 upon 4. Okay, consider this as equation 1, this as equation 2. Anything else left? No. Fine. Please check this. Till this equation, anyone is having any question? Simple Ohm's law, formation of the equations. So I don't think there will be much chat required.
Sir, can you show previous slide?
Yeah. Yeah, that previous slide means yesterday's slide.
Previous slide is yesterday's.
Yeah.
Okay. Next. Yes. Okay.
Fine. So I think all of you can see this. Now what do you have to do? KVL, KCL, KVL. So KVL, KCL, KVL. जैसे मैंने आपको कहा था ट्रायंगल दैट यू कैन रिमेंबर. सो यहाँ पर आपको अप्लाई करना है KVL. अब KVL आपका कहाँ अप्लाई होगा? लूप 2. सो लूप 2 में आपको इक्वेशन क्या मिलेगा? लूप 2 में देखते हैं. यहाँ का ब्रांच वोल्टेज आपके पास है VA, यहाँ का ब्रांच वोल्टेज है VB, और यहाँ का वोल्टेज आपको मालूम नहीं है, बट वोल्टेज ड्रॉप आप लिख सकते हो क्योंकि करंट और यहाँ का ये पैरामीटर आपको मालूम है. सो यू कैन राइट इट एज VA इज इक्वल टू IB into 2S plus VB, बराबर. Okay, now implies put the values. VA is equal to value of IB is that can be written from equation 2. So SV2 upon 4 IB का value. Okay, So I write 2s first, then s v2 upon 4 plus vb is equal to v2. So therefore I have to write this. Now what I get? 2 2s are 4, right? S square. So I am getting s square, okay, upon 2. Okay, then v2 plus v2, s square, s into s square, 2 2s are 4, so therefore it is 2 v2 plus v2. Now I am taking v2 common from this equation, therefore I get the expression for va. What I get is s square upon 2 plus 1 into v2. This is expression number 3. Expression number 3. Okay, then apply KCL. KCL. Now where you have to apply that KCL? At node A. KCL at node A. Abhilasha, is it required to apply KCL at node B? Abhilasha?
Sir.
Is it required to apply KCL at node B?
No, sir.
Why?
Sir, because is 0.
Why KCL at node B is not required? Okay, Aishwarya, why that KCL at node B is not required?
The current is 0.
Pardon?
Hello.
Yes.
The current there is 0.
Yeah, yes. At node B, yes, there are two currents, but one of the current is equal to 0. Therefore, no need to apply KCL at node B, and hence we are applying KCL at node A. Okay, so this is node A. So what do you get? Yes, tell me. Node A का KCL क्या रहेगा? I1 is equal to IA plus IB. Okay, now implies I1 is equal to IA. Value of IA is 3VA upon S. So I just write 3 by S into VA plus IB is S by 4 into V2. Okay. Now here I don't have value of V2, like no need to write the value for V2. So I directly write the value for VA. The value of VA is this one, equation 3. Equation 3. So 3 by S in bracket VA ka value. Put the value here. S square upon 2 plus 1 into V2 plus S by 4 into V2. So this is the value of I1. Okay, now just check the equation for G12. What is the equation for G12? See, we have to solve this equation further. But let me know the equation for G12. It's a voltage transform ratio. As Atish said, it is voltage transform ratio. Okay, I changed my slide.
V2 by V1.
Yes, V2 by V1. It means you have to further take the KVL to this. Yes, further you have to take KVL to this loop. Then you get the equation to V1, right? So let us solve this equation.
Sir,
Yes. 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 Okay, any doubt till this point? Okay, so I just take I1 common from this equation. So I1 is equal to V2 common from this equation. So V2 common निकल गया, आपको bracket मिल रहा है 3 by S. So 3 by S multiplied by S square upon 2. हाँ, पहला term मैं multiply कर रहा हूँ. So what I get is 3/2 बराबर है 3/2 एस गेट कैंसिल सो आई गेट 3s/2 पहला टर्म मेरा आ रहा है प्लस 3/s ठीक है ये दो टर्म्स हो गए प्लस s/4 ओके अब इसको फर्दर सॉल्व करना बहुत जरूरी है टू गेट द नेक्स्ट इक्वेशन तो यहां पर आपको एलसीएम लेना होगा तो एलसीएम इसका क्या आएगा एलसीएम इसका क्या आएगा टेल मी व्हाट शुड बी द एलसीएम टू दिस पर्टिकुलर ब्रैकेट्स टर्म okay LCM is 4 into s LCM is 4 into s right 4 2s are 8s लेने की जगह you take 4s as LCM okay so 4s LCM अगर आपका आ जाता है 4s LCM अगर आ जाता है तो 4s यहां पर मल्टीप्लाई होगा 2 2s are 4 and 2 3s are 6 so you get 6s square so I1 is equal to V2 ब्रैकेट के बाहर पहला टर्म आपका आ रहा है 6s स्क्वायर प्लस और आपने एलसीएम लिया हुआ है 4s तो फिर से एक बार बताता हूं 4s यहां पर आप मल्टीप्लाई करोगे 4s इमेजिन करो 4s है यहां पर 2 2s are 4 2 3s are 6 so 6 into s स्क्वायर यानी s into s 6s स्क्वायर प्लस अब देखते हैं यहां पर 4 into s 4s s get cancelled 4 3s are 12 so next term is 12 next 4s 4 4 get cancelled you get s into s square so it is equal to v2 okay then if you want you can take 1/4s yahan par and in bracket write down 6s square plus s square 7s square plus 12 this is your equation 5 3 yes this is your equation 4 equation 4 यानी KCL आपका हो गया now you have to apply equation 4 now you have to apply KVL आपको KVL लगाना है लूप 1 में KVL लूप 1 ओके अब KVL लूप 1 में आपको मिलेगा V1 क्योंकि आपका लेफ्ट हैंड साइड V1 है इक्वल टू V1 इक्वल टू I1 क्योंकि वहां का रेजिस्टेंस है 1 सो I1 प्लस VA I1 इंटू 1 है अच्छा चलो ठीक है लिख लेता हूं मैं यहां पर 1 इंटू I1 इज इक्वल टू नाउ I1 का वैल्यू यहां पुट अप करें V2 1/4s 7s स्क्वायर प्लस 12 VA का वैल्यू पुट अप करें अब VA का वैल्यू आप लोग जानते हो इक्वेशन 3 से आ रहा है ब्रैकेट में s²/2 प्लस 1 s²/2 प्लस 1 अच्छा मैं एक काम कर चलो ठीक है s²/2 प्लस 1 इंटू V2 अब यहां पर फिर से V2 कॉमन है मैं इन दोनों टर्म्स को कॉमन निकाल लेता हूं सो आई गेट V1 इज इक्वल टू V2 बराबर एंड इन ब्रैकेट ओके सो नाउ आई एम गेटिंग व्हाट s7s स्क्वायर प्लस 12/4s ठीक है प्लस s²/2 प्लस 1 1/4s को यहाँ ब्रैकेट में दे दिया सो आई एम गेटिंग 7s स्क्वायर प्लस 12/4s प्लस s²/2 प्लस 1 अब इसको सॉल्व करें यहाँ पे फिर से आपको एलसीएम लेना होगा एलसीएम फिर से आपको 4s रहेगा ओके एलसीएम इज 4s फर्दर सॉल्व टू गेट द प्रॉपर टर्म सो 4s से मल्टीप्लाई करें तो यहाँ 4s कैंसिल हो जाएगा एलसीएम है आपका फिर से 4s so you get 7s square plus 12 okay plus 4s 2 2s are 4, so you get 2s cube. बराबर है 4s, 2 2s are 4, so 2 into s square, 2s cube plus 4s, 1 multiplied by 4s. Okay, do we have 4s term? No. So it is equal to now v2 v1, okay, square bracket, पहला टर्म हम लोग s क्यूब का लिखते हैं, so 2s क्यूब plus 7s square plus 4s plus 12, okay, upon 4s. See, I am writing for everyone. If one or two students have completed their work, it's good, but he has or she has to wait because the others are writing the terms. Now what do you need? You need G12. What is G12? It is V2 upon V1. So I am taking V1 here. It means I have to take that complete term on left hand side. So what I get is 4s upon 2s cube plus 7s square plus 4s plus 12. Sharu Chubais. So you have 4s, 2s cube, 7s square, 4s plus 12. Yes. So this is your final answer. Kindly check. Okay. Do anyone needs that previous slide? I think यहाँ पे मैंने काफी अच्छे से मैनेज किया हुआ है इस स्लाइड में, so you don't need to refer this because you may have completed the slide. So just check this slide. Students are still that like tell others that they can join the class, no issue. Important thing is you have to attend the class. Don't miss single class because it is very, very important. Okay, anyone is having any question? Any question on this particular topic?
Sir, can we use mesh analysis?
Yes, you can use mesh analysis, no issue. Mesh analysis is nothing but the KVL.
Okay.
Okay, if you have done with the second numerical, let us take one more numerical to solve. All of you done with this slide? Shall I take next slide? Okay. ये दो न्यूमेरिकल्स मैं आपको अभी दे रहा हूं that you have to solve now only. ये है आपका समर 14 न्यूमेरिकल was asked for 6 marks. This is numerical number 3. Okay. Find the network shown, for the network shown, determine the transfer function. Yes. Determine transfer function. See, everyone has to participate. Huh? Don't assumption that sir is not knowing anything. I am going to ask you the question to anyone. So it means you have to be present, you have to be attentive. Okay, fine. So attempt this particular numerical. If you are thinking that the same kind of numericals are asked, no, we have the other set of numericals also. But before going into the difficulty level, like we have to increase our difficulty level in steps. Okay, this is 1 farad. This is 1 farad. This one is 2 ohms and 2 ohms. Hardly you need 5 minutes to get the answer, huh? Because only resistance is present and capacitor definitely goes into numerator. V2. I2 is equal to 0. This is numerical 3. Okay. And in numerical number 4, they said determine the voltage transfer ratio. Determine the voltage transfer ratio. Okay, but the ratio which they have asked is in this pattern: V0 of S upon Vi of S for the ladder network shown in figure वगैरह वगैरह. Okay, so it means they have given this. अब ladder network में what they have given? Resistance R1, resistance R2, capacitor C1, capacitor C2. Okay, this is V1 with current I1 present. The other side port V2, the I2 value is equal to 0. Okay, this particular numerical was asked in summer 15 for 7 marks. Summer 15 for 7 marks. Yes, you have 10 plus 10, 20 minutes to get the answer. I think 10 minutes is more than sufficient, but still you can take those remaining minutes to get the 4th numerical answer fast. All of you please write down this. Now we are going to increase the difficulty level as per the sets asked. Guys, tomorrow I am taking your first lecture 10 to 11. Maths 3 ka lecture 10 to 11. Students, as per our today's schedule, after 12 noon, there will not be any lecture. You have lectures only up to 12. And the reason behind of shifting this particular lecture as per our yesterday's talk is due to the mini project Viva, which is going to start from 11 o'clock. Good morning, sir.
भेदभाव नका करू. त्याची काळजी घ्या आणि या रोगापासून वाचण्यासाठी जी आपली ढाल आहे, जसे आमचे डॉक्टर, आरोग्य कर्मी